We are now going to discuss problems concerning relative velocity, relative acceleration approach in one-dimensional motion along a straight line. Okay, now uh, if and when you are coming across problem which is involving the motion of two bodies simultaneously, then you can apply this relative velocity, relative acceleration concept for solving such problems very easily. You can also solve by means of applying your regular formulas, equations of motion individually for those two particles. But then it will be much more convenient, much more easy, much more quick, much more faster, much more error free if you can apply this relative velocity concept. It actually is pretty simple. Now, this, as I said, I'll just repeat. Whenever you are having any problem which is involving two bodies motion along a straight line, please apply the relative velocity approach. It will be a faster method. Now I'll now explain about what is this. Suppose now you are having two bodies A and B, and then moving along straight line. Now we are now in this chapter we are restricting only to motion along a straight line. Therefore, now we are not considering now two bodies moving at different angle to each other. Okay, they should be moving along the same straight line or along the parallel straight line. That means along the same directions. Then and only then we are not talking about it. Okay, this particular relative velocity approach, relative acceleration approach holds good for any kind of a motion on a plane or space, etc. Not necessarily only for straight line. Whereas now we are going to take up examples only pertaining to straight line motion because we are in this particular chapter. That's the only reason. Okay. Now coming back to explaining what is the concept of relative acceleration, relative velocity. Now most of you may be already aware of it, but anyway we'll just have a revision of what is involved in this. Now suppose you have let us say now the straight line on which now two bodies A and B are moving. Let us say now A is here at time t equal to 0. We are talking about now the position of this body. Now A and B may actually be together at this particular point, or maybe at a distance apart. Let's take a general case. Let A be here as I have marked, and then B is here. This is at time t equal to 0, and they have been traveling along this straight line towards right. Now at this particular time, initial time, let A have certain velocity, that is u equal to, let us say, 4, and then acceleration also is traveling constant acceleration 4, and then let B have initial velocity at this time as 1, and then acceleration as 2. Now when they are going like this, now it is quite obvious. You can actually conclude that sometime soon A is going to now this distance between them, let's call it, let us say, now 10 meters initially. Therefore now as we see it now because A is having a faster initial velocity plus much more important is faster acceleration, sometime soon A is going to overtake B. So now the question is like this now: who overtakes whom first, and then at what time, and after traveling what distance? Therefore now this is a question. I given the data. Now as I said, we can also solve it by means of your applying equation of motion for individually for A and B also, but then it is much more convenient. Now let's start with relative velocity. Therefore now what I am going to say is now relative to whom. Now we can also take that is A relative to B or B relative to A, whichever is your choice. Okay, more convenient, whichever you feel convenient or whichever strikes you, you just follow. It doesn't matter because we will get the answer whichever way we apply. Okay, but then I would rather say that you take this, well, all quantity, all calculation is B relative to A. Okay, why I have chosen B relative to A? There is no specific reason except that I would rather prefer now the advanced particle which is there is first is B. Okay, A is behind. Therefore I'll know I have no logic, no preference, but still I would like to keep now B relative to A. Okay, you are perfectly. I'll also now work out. Now same thing is with the other alternative, or with reference to A related to B also. Let me just also now side by side work it out. Now first let's now take all calculation is B relative to A, which means now what is a U? That means U. What is meant by relative is if you're not talking about relative to A means we want to keep A at rest. Now, how do you keep A at rest? Because A is already having a velocity as well as acceleration. How do you keep it at rest is by simply applying a negative value. Like for example, now in this case, now A is having a initial velocity u equal to 4. Now apply a minus 4 velocity on A. Therefore, now it has got 0 velocity initially. That is what now, and also now it's got acceleration also 4. Therefore, now you apply a negative acceleration to A. Therefore, minus 4 you apply. Therefore, you are now applying initial velocity minus 4 minus 4. You are subtracting the initial velocity, therefore making it to 0. And also acceleration also you must make it to 0, because then and only then you can truly say A is at rest. Therefore, now whenever you say that something relative to A means A should be made to be at rest. Okay. And how do you make it? Is you just now subtract velocity acceleration values of A from A itself. Now, not only that A, because if you are applying negative velocity of A and negative acceleration of A to A, you must also apply the same thing. You must also treat all other objects to be the same way, which means you have to apply equally negative velocity and negative acceleration to all other objects, including the ground also. For example, now if you are now traveling on a bicycle, then you just look at the ground, you feel that the ground is going backward with your velocity. No, how is it? Because you are applying a negative velocity. Because you are looking, that means now the reference frame is only u. Therefore, now what is the velocity of ground with reference to u is 0 is absolute velocity of the ground minus, because you are not subtracting your velocity in order to make u at rest. Therefore, now very similarly here also now we want now all calculations to be relative to A. Therefore, now we are now talking about the velocity of u, that means velocity of B relative to A. B relative to A, we must actually write it, but then because already I have now put it on top saying that all calculations are based on B relative to A. I'm going to omit this particular B relative to A every time. Okay. Therefore, now let me say this is nothing but which we know is UB minus UA, because we are making A at rest. Therefore, now what happens is, now UB minus UA is, UB is 1 minus UA is 4, therefore it's minus 3. Then similarly, now acceleration of B relative to A is acceleration of B is 2 minus acceleration of A is 4, therefore equal to minus 2. Then we are going to apply the formula S equal to ut plus half at squared, because we are asked to find what is the time at which somebody will overtake somebody else. Therefore, now we will now apply for this minus 3t plus half into minus 2 into t squared, which is nothing but minus 3t minus t squared. Now this should be the displacement of B, that is what we understand as VB relative to A. Okay. Now this means what should be the, now if somebody has to overtake somebody, then the displacement of B, that means we are now keeping A at rest. We are now keeping A at rest by means of relative approach. We are keeping the A at rest. Therefore, now B should have in order to have B and A to be at the same place, B should now have a negative, because we are taking forward as positive, backward has to be negative. That means now the SB relative to A should be equal to minus 10, so that they will be at the same point. Okay, I'll just repeat. Now, since you are taking a relative to A is at rest. Therefore, now if now anyone has to overtake, means both should be at the same point, which means A is at rest. Therefore, A is not moving. Therefore, B should move backwards in order for this overtaking to happen. Okay, that means B should have a displacement. What should be displacement? Should be minus 10, so that B meets A. That's the logic of this. Therefore, it is minus 10 should be equal to minus 3t minus t squared. Now, which value will give you this? This can be taken as t squared plus 3t minus 10 equal to 0. Okay. Now this will have t equal to minus 5 or plus 2. Therefore, time minus 5 is not allowed. Therefore, we now take plus 2. Therefore, now the first question. Now, obviously, then who overtakes whom? Because situation is very clear that both of them are moving forward. Then naturally, now A has to overtake B. The answer for the first question is A overtakes B. It is obvious. Then the second thing, at what time? at time t equal to 2. Then after traveling what distance? Now that means they are asking about how much distance b, because we are not talking about a overtaking b. Therefore, how much distance a travels? A travels how much distance, we have to give the answer. Okay, I just repeat. The question is who overtakes at what time and then after traveling what distance. Therefore, we are now concluded that A overtakes B. Therefore, at what time t equal to 2 seconds and by which time A has traveled total distance. Then we have to apply this particular time t equal to 2 to the A's equation alone. What is A's equation? Travel distance of S of A is U of A is 4, t is 2 plus half into A of is 4, half A2 into t squared is 4 equal to 8. Therefore, this is equal to 16 meters. Okay, after traveling 16 meters. Therefore, then all the three answers have been given. A overtakes at time t and then after traveling 16 seconds. Now we have now understood this. Now I am going to now do the same thing with assuming that all are now relative to b. Okay, they all are relative to b now. Now I am going to say that, which means what is u of a related to b is what we are going to do. Which means what is u of a related to b? 4 minus 1 equal to 3. Then what about acceleration of a relative to b? 4 minus 2 equal to 2. Then and therefore what is now displacement equation for the relative? S equal to ut 3t plus half a is 1 into t squared. Now what should be the displacement? Now b is now stationary because we have now taken all relative to b, which means b is at rest. Therefore now for a to meet b, a should have a displacement of plus 10. Therefore s should be equal to plus 10. That means now 10 equal to 3t plus t squared. That means t squared plus 3t minus 10 equal to 0. It is now the same equation as what we have got. It will have t is equal to 2 as the only answer, and after traveling how much distance. Therefore now again now same as SCA equal to 16 meter, you will get it. Okay, therefore now it is now the same. It doesn't matter which is, whatever you feel convenient, you take relative to that. Now I am going to now show that if we don't, suppose we don't apply the relative velocity, relative acceleration concept, then still if we now apply individual equations, we should get the same answer. That I am going to now show it to you. Okay, just for the sake of understanding. Afterwards, I still maintain that whenever you have two particle motion, please apply relative concept only. That will be the much faster, much easier method. Okay, much quicker method. Now let me now apply this concept for individual equations. Individual equation we will now solve. Okay, therefore now SA calculation is 4t plus half 4 into t squared, 2t squared. Now SB is calculation is ut is 1t plus half a is 2 into t squared. Now this is SB. Then what is the condition? SA. Now A should travel, that means now the condition for overtaking is A should travel 10 meters more than what B does. Okay, 10 meters more than what B does. This is the condition for overtaking. Therefore, this means 4t plus 2t squared must be equal to 10 plus t squared. Therefore, now you do it now, take it to one side, t squared plus 3t minus 10 equal to 0. The same relation what we have got earlier. Understanding? Therefore, both are same, but then it will be more convenient to do only one equation like this. Okay, now I leave it to you. Depending upon whichever convenient you can do. Now in this case, now apply this SCA and SB separately. Also is convenient enough, and also is actually very short only way of working only. Therefore, I just leave it to you whatever you feel convenient. But then I would personally advise you that whenever you have to, you please apply relative concept. That will be much better. Okay. Now this is what it is. Now there is one more kind of a reason why I am advocating relative velocity rather than individual equation calculation is, especially if this happens to be in the vertical situation. The that is motion under gravity, then you would find that the acceleration of the two bodies will be equal because both are g downward. Therefore, when you do the relative calculation, acceleration vanishes because a of b related to a or a of a related to b both will be nothing but g minus g will be equal to 0. Therefore, now you have a situation of straight away having no acceleration in the relative frame. Therefore, it will be much more convenient. Okay, we can actually now show. I'll now show this by means of taking an example on the gravity situation where the free fall from under gravity. Okay, not free fall exactly, but then moving under gravity of two bodies. So that I'll also show you that how it is much more convenient rather than applying individual equations. Then you will have to apply the gravity g for both the equations. Whereas when you apply the relative acceleration concept, acceleration vanishes. Therefore, there will be much more convenient to use a relative acceleration approach. That's the reason why I say that for all situations, I would rather prefer you to use relative approach. Okay. Now, having said that, as I told you, we'll now take up a case of a gravity, the vertical direction motion of two bodies, and then we will see that how this particular approach helps. Let's take this example for vertical situation. Let's take now this is the ground, and there is a tower 20 meters high. 20 meters high, and then from the top of the tower, object A is vertically thrown upwards with the initial velocity of 6. And then at the same time, B is thrown vertically from upward from the ground with the initial velocity of, let us say, 10 meters per second. Then what happens is, we are now trying to find out, now same question, where do they meet? Where and at what time? Okay, initial time equal to 0. Where and what time do they meet is the question. Therefore, now we apply. Okay, what do you want to take? You want to take now relative to A or relative to B. Okay, anything can be chosen. Let us now take all are relative to B. Okay, that is A relative to B is a approach we are going to take. Therefore, then what happens? What is now U calculation is A 6 minus 10. 6 minus 10 equal to minus 4 is a U. What about acceleration? Equal to both will be equal to minus 10 minus of minus 10 equal to 0. That's the reason why I said it is much more convenient. And therefore then what is the equation of S of A related to B is equal to UT. UT plus half AT squared happen to vanish. Therefore yes UT. Therefore then for meeting what is the condition, you want displacement of A. Because B is at rest, displacement of B, this should be equal to minus 20. Right now? Therefore this is actually happen at t equal to 5. Now at t equal to 5, where do they meet? You can take any one of them. Let's take now B convenient because it is going upwards. Therefore let's now take B and then say that B is calculation is, therefore S of B is equal to 10 into 5 minus half gt squared, 5 into t squared, 25. That means it is 50 minus 125. Actually speaking, in this particular case, it is actually meeting down below minus 75 below the ground. Okay, we assume that let us say now this got to be minus. Okay, yeah, that because of the data which you have chosen shows that it got a minus displacement. Which one? SB. Okay, you can check up at the same this thing. What is the SA also? SA also will be equal to 6 into 5 minus 5 into 25 equal to 30 minus 125 equal to minus 95, which is correct because A has to travel 20 down and 75 down. Okay, now don't worry, we are getting a minus answer because of the kind of a data what we have chosen for demonstration. Therefore now if you assume that there is a kind of a valley below the ground, then they are meeting at this minus 25 point. Okay, whereas now we have answered it very clearly. At time t equal to 5, they meet. Okay, fine enough. Now if we do the same kind of calculation, because calculation now become very simple because the g gets cancelled out. Now if we have to do it now by means of regular calculation approach of applying the equation for both A and B separately, we can still do it. and then you get the same answer as I will now demonstrate to you. Now let's now take A. Before S of A equal to ut 6t minus 5t squared. Then S of B will be equal to u is 10, therefore 10t minus the same 5t squared. Now what is the condition for their, and therefore then what is the condition for meeting? Now SB is below 20 meter below, therefore now SB should be 20 more than, condition for meeting SB should be 20 plus whatever is SA, because both are upwards is our sign convention wise. Therefore SB should travel 20 more upwards than SA. Therefore now we have this equation 10t minus 5t squared should be 20 more than 60 minus 5t squared. Therefore naturally you can find that you have to 5t squared gets cancelled off. That means 4t equal to 20 or t is equal to 5. And therefore now we apply the SB situation. SB is equal to 10 into 5 minus 125 equal to minus 75. We are getting the same answer again. Okay, understood? Therefore now both approaches give the same result. We find it. But then if it is a gravity situation, it is much more convenient to apply relative velocity approach, as you could see. Okay, now with this we will now go to some of the past PYQs and then apply this particular concept of relative velocity to acceleration and then see how we can solve them. Now, okay, we'll apply to the past asked questions. Okay, a ball is dropped from a high-rise platform at t equal to 0 starting from rest. So let's just now make a drawing. Okay, this ground, there is a tall building and from the top a ball, let us call it as A is getting dropped, A with u equal to 0 is getting dropped. Then this is at time t equal to 0. Then another ball after 6 seconds, that means at time t equal to 6 seconds, it gets thrown downwards with the initial velocity speed v. Now the two balls meet at t equal to 18 seconds. What is the value of that v? Now what will such cases where is not getting that is relative, we can apply only if the simultaneous traveling. Whereas now A is advanced by t equal to 6 seconds earlier. Therefore now first stage what we'll have to do is we'll have to find out where the A will be at time t equal to 6 seconds and then with what velocity. Then further problem we can actually do by means of relative velocity approach. Therefore now at time t equal to 6, what will be the velocity, because it is now g, therefore now velocity of A will be equal to ua at time t equal to 6 seconds, ua will be equal to 6 into 10 equals 60 downwards. Okay, and then where it will be at half gt squared, that is 5t squared downwards, that is equal to 5 into 36 is 180 meters down. Okay, 180 meters down anyway it will be, whereas I think that we don't need that particular S calculation at all, because they are not asking anything about where they are meeting. They are only asking about what will be the value of V so that they meet at t equal to 18 seconds. Therefore we can ignore further calculation about the S where A will be after 6 seconds. We don't have to bother about that. Okay, right now supposing now they are asking question where the crossing takes place, where they are meeting, then and only then we require that particular S calculation. Otherwise we don't require it. It's enough if we just calculate after 6 seconds what will be the velocity of A. Okay, that means now A will be somewhere down like this with a velocity of ua equal to 60, and at that time ub gets dropped with a velocity of ub equal to v. Now therefore now from now onward, now it says that at time t equal to 18 seconds, which means actual time of this thing is, we have to take it as t equal to 12 seconds, because after 6 seconds we have already now shifted the origin of the time by 6 seconds. We now talk about, therefore they are meeting at t equal to 12 seconds. Therefore then what should be the value of b such that, now we will apply now we will now take ub relative to a. That means it is nothing but v minus 60 is the relative velocity of b at this time. And as I said, because it is under gravity, we can ignore the gravity because they get cancelled out. Relative acceleration equal to 0. Therefore now simply it is like this. Now this is your ub which is required, ub relative to a is this what is required, and then Oh yes, we require that 180 calculation, SCA calculation, we require it because we need to now apply that particular S. Therefore, SB relative to A should be equal to 180 meters. You should actually travel because now that we are assumed relative to A means we are keeping A at rest. Therefore, B has to meet A means you should travel downwards by means of 180. Therefore, all are only downwards we are taking 180 meters. Therefore, we require the calculation of 180 meters. 180 meters and therefore what is now the condition is v minus 60 into t is 12. This should be equal to 180. Therefore v minus 60 equal to divide by 12 becomes 15. Therefore v should be equal to 75. Yeah, okay. Therefore we require the calculation also 180. Okay, fine. Therefore now answer is 75. So you saw how we have applied this. Therefore, as I said, if there is going to be a time difference, then better to calculate individually for that particular time difference of t equal to 6 and afterwards apply the relative velocity approach after determining at time t equal to 6 where A will be at what velocity. From that time onwards, you can apply the kind of relative velocity approach what we have done and for which now gravity anyway gets cancelled out. Understood? Fine. Now we'll go to the next question. Read the problem. Your ball is projected vertically upward with an initial velocity of 50 meters per second at time t equal to 0. Okay, let's now take this is now the drawing. This is a ground. A ball A gets projected at time t equal to 0 with the initial velocity 50 meters per second. Then at time t equal to 2 seconds, another ball projected vertically. Therefore, now let's now calculate for the 2 seconds where and then what velocity the A will have. Therefore, A will have velocity, that is u of A at time t equal to 2. U of A will be 50 minus 2 into G is 20 equal to 30. 30 upwards. Okay. We will not take all upwards as positive. Therefore, UA is 30 and then where it will be. Now we can actually find out by means of this average velocity 50 plus 30 by 240 into 2 will be 80 meters above it will be. This will be the place where it will be. Okay, just now check it once more. Now U is 50, B is 30, therefore 50 plus 30 by 2 average velocity 40 into 2 seconds 80 meters above it will be. Therefore now A will be at this point with the initial velocity of 30. Okay, 180 meters. Now at that time then B gets projected with the projected vertical upward with the same velocity of 50. Same velocity of 50 meters vertically upwards. Then what time they will meet? That means now what is now the relative velocity? Let's now take everything relative to A. Okay, everything relative to A. That means B relative to A. B relative to A therefore is VB UB minus UA is 20 plus 20. Then the G gets cancelled from 2 seconds onwards. Therefore, now we have to now take it as, therefore, S B relative to A is 20t. 20t should be equal to how much? 80 meters. 80 meters. Therefore, t is equal to 4 seconds. This is after 2 seconds. Therefore, they are asking at what time t. We have to add that 2 seconds and say that 6 seconds is the answer. Okay, therefore, answer is equal to 6 seconds. Understood? Fine. Now, let's now take the next question. Okay, let's read this question. Two balls A and B are placed at the top of 180 meter tall tower. So now let us now take the drawing. This is now ground. This is the 180 meters tall tower. 180 meters. Then two balls are placed. Then ball A is released from the top at t equal to 0. That is released from rest means free dropping. T equal to 0. Then ball B is thrown vertically down with the initial velocity u at t equal to 2 seconds. Therefore, now ball A has got an advanced lead of 2 seconds. Therefore, now at t equal to 2 seconds, we'll just find out what is the velocity of A will be equal to 2 into G will be 20, and also then what will be the position of, what will be displacement of A in that is, now average velocity 20 plus 0 by 2 into 2 will be equal to another, yes, A also will be equal to 20. Therefore, per t equal to 2 seconds, that means now ball A would be here, this is A, with the initial velocity of UA equal to 20, and then at a distance of 20 meter from top. Okay, at this, okay. Now this is at t equal to 2 seconds. At that time, what happens? Now ball B is thrown vertically down with the initial velocity u at t equal to 2 seconds. That means now this is ball B. Ball B gets thrown with the initial velocity. Let's call it as u. Therefore, now this is now thrown with initial velocity u. From that time onwards, we can neglect the g value because it gets cancelled out in the relative acceleration approach. Therefore, now it's like this now. Then what is given is, after a certain time, both balls meet 100 meter above the ground. That means they are meeting here, somewhere here, 100 meters above the ground mean. Then this is 20 mean, this should be 60 meters. Okay, and therefore then what is it? Okay, now what is the question asked? What is the value of that u of b? Now let us now take the approach of that is relative to a. That means all b relative to a. Therefore now initial u of b relative to a. Okay, at t equal to 2 seconds is what we are now starting with. Therefore we have to be careful about applying the time values. Anyway, now this is ub relative to a is ub relative to a is 0. This is u is the, and u is a variable. Okay, let's not confuse this u. Let's call the variable as v. We'll have to find out the value of v. Okay, this is the value of v. We'll have to find it out, because without confusing with u, I want to change it to v, so that we'll finally find out what is the value of v and then report it. Therefore, this is v minus what is the value of a at that time is 20. Therefore, this now the starting value u b relative to a. Of course, now g gets cancelled off in the relative approach. Now, what we'll have to now find out is, now what is the time? Okay, time t. Time t. Therefore, this should be equal to v minus 20 into time t should be equal to the 20 meter displacement what b should be, because we are now taken a to be at rest. Therefore, b should cover a distance of 20 meters in the particular time. Now this particular time t is after 2 seconds. Okay, remember that. Now therefore this is now one equation, because there are no two unknowns here. Then what the second equation is? You have got. Now we'll have to have a second equation. How is like this is, now a should actually travel starting from 0 velocity. A should travel 20 plus 60 for meeting at this particular point 100 meters from the ground. A should have traveled the total distance of 20 plus 60 by that time. What is the time at that time? Now t plus 2 seconds. That means half gt square, because a is getting dropped with the initial velocity equal to 0. Therefore, half g, that is 5 into t plus 2 whole square. Okay, this is for travel of a. This should be equal to 20 plus 60 is 80. Therefore, this is now your second equation. Therefore, from here now you get t plus 2 equal to divide by 80 by 5 is equal to 16. Therefore, this should be equal to 4. Therefore, t should be equal to 2. Therefore, put this in this particular first equation, t equal to 2, you get b should be equal to 30. 30 should be the answer. Okay, now this kind of a difficulty of the problem is actually beyond NEET level. Therefore, what now I had explained, only JEE students need to be bothered about this kind of a slightly more difficult kind of this thing. In the sense, we need to actually calculate after t equal to 2 seconds the position of a as well as the velocity of a, and then the kind of ticklish question asked, because they are not given the time value of meeting, because they are saying after a certain time. After a certain time, both meet 100 meter above the ground. Therefore, we have to actually calculate that particular 60 meter plus 20 meter, and therefore apply the second equation. We have to develop it. Therefore, this actually is beyond the NEET level of difficulty. only for JEE level. Therefore, NEET level people need not bother about this particular thing in detail. Okay, that be good for their own brain practice if they have understood this particular aspect of it. But then they don't have to worry about getting such kind of a question in the NEET. Okay, now this read the next question. Two spherical balls having equal masses of radius 5 cm each are thrown upwards with the same vertical direction at an interval of 3 seconds with the same initial velocity of 3 meter per second. That means we are now having a situation like this. Now this first ball is thrown upwards with a velocity of 35 meters per second, and after 3 seconds the second ball is very similarly thrown. That means now after 3 seconds, therefore that's called ball A. Okay, ball A gets thrown, and then after 3 seconds its velocity will be 35 minus 30 will be 5. Okay, therefore it will be, this is A, and with the velocity 5, and then and therefore then what will be the height from the ground, because 5 and then 35, therefore average is 20 into 3 seconds, this is 60 meters. Therefore A will be at a height of 60 meters from the ground and with a velocity of 5. This is at time t equal to 3 seconds. At this time, now the B gets thrown with the velocity of 35. Therefore, now from then onward, then there is no G calculation because they get cancelled out in the relative acceleration. Therefore, now the question is, therefore the velocity, we are now going to do B with respect to A. Therefore, now it is 35. U will be equal to 35 minus 5 equal to 30. This is just very similar to what we have done earlier. Also one more example what we did. Then the U equal 30, and then it's got to cover a distance displacement of this thing is 60. Therefore time will be equal to 2 seconds after the 3 seconds. Therefore then the question which is asked is, then these balls collide at a height of how much? Now which means now we'll have to now calculate what is the height which is B. Therefore SB is nothing but 35 into T minus 5 into T squared equal to 70 minus 20 equal to 50 meters height will be the collision. Understood? Okay, fine. So then that's all.